So before I move on to the question, just a little bit of um, knowledge that I think will help solve it. So there are three cases of hypothesis testing that you can have, like three cases of three particular types of null and alternative hypothesis. So your null hypothesis, like if it's let's say if it's there for a normal distribution where you're obviously be testing mu, your mean, it always has to be equals to a particular, let's say, fixed value. So a particular fixed, or maybe a better word is specific value, and it has to be always be equals to that. I can't say that my null hypothesis is that it is my mean is greater than something. Your null hypothesis has to be a particular fixed value, and then you might challenge that in your alternative hypothesis. So it could be like my mean is equals to 17.0, my mean is equals to 18, my mean is equals to 20. It can't be greater than or equals to, or a range of values. That's what I'm saying. Okay, and for your alternative hypothesis, that can challenge your null hypothesis by either saying that, let's say, the mean is greater than the particular null hypothesis. So whatever you have here, it's greater than, let's say, 17. It's less than, let's say, 17. Or it's not equals to, let's say, the particular null hypothesis, which is why your null hypothesis has to be a specific value. So that your alternative can be greater than that, less than that, or not equals to that, which is basically where we say not equals to, it means could be greater or lesser. They haven't really specified. That's the idea. Now, in this particular question 2, this was a little tricky because it was a little difficult to figure out what the null and alternative hypotheses were. Now it says the times taken by students to complete a task are, well, they're normally distributed with standard deviation of 2.4 minutes. A lecturer claims that the mean time was 17. The times taken by a random sample of 5 students were these many. Carry out a hypothesis test at a 5% significance level to determine whether the lecturer's claim should be accepted. Now, the reason why some people got a little confused with this is because normally when in these questions they're phrased in such a way that your claim is when someone is claiming something, they're normally challenging the null hypothesis that exists. Like a person's claiming that the mean has decreased, for example, of the centimeters a plant grows. Normally they're phrased like that, but don't just synchronize yourself with the phrasing. Understand here that you can get a particular value for the mean from this, which you will calculate. Uh, but the fixed value that you have, the value that is specified, that is fixed in this particular case, is 17. In this particular case, we can in fact say that your alternative hypothesis is that population mean is 17 minutes, and the null, like this is what your lecturer is saying, and the null hypothesis, because we don't know whether it's greater than or equals to, they haven't specified that in the question, we can simply say it is not equals to mu. And since they want you to test this at a 5% significance level, and since it's a two-tailed test, that 5% would be divided. So this would be your 2.5%. This would be the rest of the 2.5%. Where do you get your x value from? You can get it from uh, the, the sample of 5 students. You have all of these values, so you just add them. So you do basically 17.8 plus 22.4 plus this, all divided by 5, and that would give you the mean of the particular sample, which you can use to carry out the test. Now that mean is coming out to be 18.2. I just added them and divided by 5. So, well, in this case, so Yeah, so what I was saying was, while they haven't specified necessarily whether it is an upper tail test or a lower tail test, and we are testing both tails, by this point, it should be pretty clear to you that since your mean is like, or your at least the mean that we're taking as our null hypothesis is like 17, it should be kind of obvious that if the value is going to be rejected, if it's going to fall in a critical region, it's going to be this one, because the value we're taking is like 18.2. It is clearly in the upper half of it. But anyhow, even if that realization doesn't hit you, it's still fine. You just need to follow a very repetitive method in S2. So 18.2 minus 17.0, and what do you have as your standard deviation? So you have 2.4. This is the standard deviation of the population. So don't forget to divide it by root n, which is n is 5. It was 5 students, remember? I didn't have to put the root over 2.4 because it's already standard deviation. If it had been variance, I would have put the root over that as well. You get a particular z value. So you get 1.12. This is the z value you get from here. And from here, like if you look at the normal distribution again, this was 2.4. Sorry, this was 2.5, which means all the probability less than this particular z value here, uh, would be 97.5, right? So you check your critical values from the normal distribution table, and you get a z value for this, and that particular z value is 1.96. If this z value is 1.96 and this is like 1.12, it would fall like, I don't know, somewhere around here. Like definitely less, it's towards the left of 1.96. It's less than 1.96. It is falling in the acceptance region, and that's what you write. You write the how since 1.12 is less than 1.96, you accept H naught. I mean, you can call this accepting H naught, rejecting H1, or just not rejecting H naught, just taking it. And again, if you remember here accept H naught was the claim of the lecturer. So you accept claim of lecturer, and that would be it.